All right. Hello, everyone, and welcome to session number 2 of those virtual IoT and Edge days. I'm Frédéric Debiet, Program Manager for IoT and Edge Computing at the Eclipse Foundation. And it is my pleasure to introduce you today to our second speaker, Gabriele Montanari. So Gabriele has quite an interesting background. He's been CEO at a startup, and then he joined Eurotech, where he had a variety of roles, and now he is playing a very important role in their IoT product strategy. And today he will tell us about no-compromised solutions for the integration between the edge and cloud. So glad to have you, Gabriele.
Hello, everybody. Thank you for joining us today. I hope you will appreciate this kind of session. So I think we can start.
Absolutely. Go ahead.
Okay, I think you can see my screen. All right. For my speech at the Eclipse Virtual IoT and Edge Day 2021, I decided to articulate my presentation as follows. First of all, a quick introduction on the main trends in the 2021 edge and cloud computing worldwide market. On that, the world pandemic is certainly one of the factors that affected the substantial increase of edge and cloud computing. Later in the presentation, we will see deepen some of the relevant aspects that what kind of perspective will emerge. Secondly, at this point, starting from the current world scenario, I wanted to focus on the reasons that lead us to lean towards distributed computing solutions at the edge. This is followed by an in-depth analysis of the main needs that results by an edge computing approach. And starting to this part, we will be possible to better understand the added value of the Eclipse software stack, articulate both in the edge framework and in the edge management platform. Later, we will focus on a summary of the main benefits of the introduction of Cura as the edge framework and Kapoor as the edge management platform. At the conclusion of our meeting, there will be a brief digression on the topic of my speech, the no-compromise integration both on the edge and at the cloud. Hope you will appreciate these kinds of themes. So let's start with 2021 edge and cloud computing market main trends. During this year's coronavirus outbreaks, the use of cloud computing technologies has exploded. Across the world, millions of users started to use cloud-based platforms to collaborate, shop online, and entertain themselves. Cloud computing technologies for healthcare have gained attention even from corporate users previously worried about privacy and compliance. As you can see, I've tried to summarize the main trends identified in 6 main points. First, cloud strategy and transformation. The top trend in the field is the evolution of hybrid and multi-cloud, connecting public clouds to other public clouds and on-site workloads. The second is cognitive and intelligence cloud. Artificial intelligence as a service is bringing services like marketing intelligence, customer service, robotic process automation, and analytics to a wider audience. Third, high-performance computing, a big data cloud. As use cases in need of fast and high processing power are constantly increasing, cloud providers are adding high-performance computing to their services, and quantum cloud is gaining popularity. Then, cloud-native technology stack. Top trends in this area are cloud automation and orchestration, cloud containers, and serverless computing for different kind of use for that. Edge computing and distributed cloud for sure, and specific on that we will go in deep in the next slide. And obviously we close 2 milestones with application and industry specific solution that focus on the actual needs of vertical that intersects IoT markets one. So there are essentially four main fundamental reasons why edge computing can play a vital role in IT architectures. First, latency, real-time or at least real-time requirements. This concerns in particular the whole part of data acquisition and transmissions, both in aggregate and in a raw form, directly from the field and with the aim of having it available in real time in order to trigger various kinds of processes. Connectivity, for sure, computing power in areas where broadband connectivity or mobile is not available. We are referring to typical of distributed IoT architectures are underground in the mountains or in the middle of the sea, for example. Security and privacy, because data availability, perimeter definition is quite important because this obviously is related in particular to law aspects that evolve in parallel with the technology. And finally, the four connection costs and transmitted data volumes. The scope is rugged data processing at the edge and gathering only the results in the cloud. Obviously, as for any solution a customer wants to introduce, the relevant aspect is certainly that of the total cost ownership must intersect rights the technological and operational aspects. Today, the market articulates its demand around three main needs. First, acquiring data from the field. Second, process each of these data in real time in the simplest, fastest, and most effective way. Third, ensure an easily third-party connection with different kinds of infrastructure. Applications, cloud instances, where you can storing data, processes, and possibly make them available through a web dashboard or other tools. All these referring to the data pipeline to which the device management platform is approached, so as to have a complete, functional, easily manageable, and scalable infrastructure. The Eclipse software stack makes all this available. It guarantees an efficient data acquisition with the most important field protocols in order to interface the edge framework to any type of field device. It also guarantees simple and intuitive data processing through an efficient edge framework, and specifically with Cura Web UI that proposes some amazing features like wires, a no-code programming solution integrated with Eclipse Marketplace, and an excellent solution for the easily integration of bundles and packages, so as to be able to create your own edge application in a few minutes, so quickly and intuitively. All of that is managed through the Edge Gateway Device Management Platform, the platform with which it's possible to control and manage all field devices, including gateways, and which allows the instant interfaces with customers' web dashboards, with open source dashboards and web analytics platform, such as, for example, Grafana, and not last but not the least, are the third-party cloud platform. On that, Microsoft Azure and Amazon IoT Core certified cloud connectors allow a quick and secure connection to the cloud and third-party services, so as to guarantee the secure connection and publication of data in most of the main cloud platforms now available in the worldwide market. As I told, all these features are then perfectly integrated with the device management platform, which allows the full control of the entire management pipeline, also guaranteeing the easily third-party platform integration using the REST APIs. In the proposed architecture, each of the building blocks can have one or more different connotations. Specifically on that, when we talk about the Edge framework, we are referring to Eclipse, Cura, and in the case of the Edge and Device Management Platform, we are referring to Eclipse Kapoor. Each of the two components we will then see deeply is based on a Java OSGI technology, which aims to make an intuitive and easy to use interface available to the different personas will work on the IoT architecture. In particular, the added value here is that everyone can intersect the complexity of the activities of the two platforms on the basis of the effective technical and not skills. A developer, for example, will be able to create his own Java modules for scratch and deploy them as packages directly from the Eclipse development environment. A product manager or an analyst manager differently will be able to take advantage using the amazing no-code and drag-and-drop features to be able to easily compose his own application flow. Going deeper into aspects relating to the no-compromise integration as mentioned above, the first goal is to be able to effectively acquire and process the field data and create an interface with different types of field device and their own field protocols. Eclipse Kapoor introduced a model based on the concepts of driver and assets to simplify the communication with the field devices attached to a gateway. A driver encapsulates the communication protocol and its configuration parameters. It opens, closes, and performs the communication with the end field device. It also exposes field protocol specific information that can be used by upper levels of abstraction to simplify the interaction with the end devices. An asset, differently, is a logical representation of a field device, described essentially by a list of channels. The asset uses a specific drive instance to communicate with the underlying device, and it models a generic device resource as a channel. In this way, each asset has multiple channels and for reading and writing also data from and to an industrial device. All of that is managed through the very intuitive Kapoor web UI. Now, the focus will be on the other side of the integration we have talked about. Specifically on that, we are referring to the one between the edge and the cloud. And in this case, we should talk about the cloud connectors of Kapoor administrative web UI that allows users to create and manage easily the cloud connection. So you can easily create your connection with Kapoor as to enable all the features of the edge management platform. Eclipse Kapoor, in fact, is a modular platform providing the services required to manage IoT gateways and smart edge devices. It provides a core integration framework and an initial set of core IoT services, including a device registry, device management services, and application enablement services. The Kapoor Gateway Administrative Console exposes all services necessary for connecting to Eclipse Kapoor through MQTT data transport. The service provides the ability to connect to a remote broker, publish messages, subscribe to topics, receive messages, and disconnect from the remote message broker for sure. But if we are referring to a no-compromise integration, however, we cannot fail to consider the cloud-to-cloud or cloud-to-third-party integration that can be achieved through the use of REST APIs exposed by our edge management platform. Kapoor, in fact, exposes REST API, which can be used to access Kapoor data and invoke Kapoor operation. REST API application is running as a dedicated Java process and allows you to integrate your IoT hub also with existing third-party web platform in an easily and intuitively way. Everything we have seen allows you to create a digital twin of a physical device. The digital twin that allows to abstract the business model of any company that wants to insert this kind of IoT solutions. And in this way, the owner will be able to manage this kind of digital twin, control it and simulate its development also in a predictive way, by integrating, for example, an artificial intelligence tool as a service directly on the edge. And we think that this looks great. But the question now is, how does everything we have already seen regarding this type of IoT architecture reconcile with what was said in the first slides, the main needs and challenges relating of IoT worldwide market? This is the question we will try to answer, going deeper on the most important features of the Eclipse IoT software stack. Edge computing enables systems to perform data processing at the edge of the network, near the source of the data. This reduces the communication bandwidth needed between sensors and the central data center by performing analytics and knowledge generation at or near the source of data. The Internet of Things service gateway model, running enterprise-level software stacks and operating on the edge of an IoT deployment as an aggregator and controller, provides the best foundation for edge computing solutions. Eclipse Cura is the open source Java SGI IoT edge framework for IoT gateways, and through its intuitive web UI enables developers to first, develop and manage IoT edge computing application. Second, easily connect to IoT devices and cloud services using IoT industrial protocols. Third, visually compose data flows to manage, analyze, and route data. Thanks to its Java OSGI basis, Cura and its applications can be ported across different system hardware architectures and can be dynamically updated. Last but not least, it prevents vendor lock-in and guarantees for sure the protection of the software investment. Cura employs a single model to simplify the communication between the device and the gateway. It first encapsulates protocols such as OPC UA so that a common format can be reused across different devices. Then it automatically creates a digital image of a device to easily connect it to the gateway and to the cloud, of course. Cura also provides APIs to interface with the input-output interfaces of an IoT gateway, like serial communication via Bluetooth 2.1 or 4.0, USB or CAN bus, for example. But one of the most interesting things is the full support for interfaces and protocol available at the Eclipse Marketplace for IoT. You can easily search, download, and install, as, for example, you can see in the picture for the Modbus protocol implementation. Cura also acts as an application container for edge computing application deployed on IoT gateways. Cura application, as we said, can be developed using plain Java code and packaged as an OSGI bundle. Cura Java APIs provide a rich set of services for data acquisition, processing, cloud connectivity, and remote management. Cura also provides a simple visual data flow programming tool named Wires to define data collection and processing pipelines at the edge by simply selecting components from a palette and wiring them together. That are these. Wires allows users to periodically acquire data from its channels, store them in the gateway, filter or aggregate them using powerful SQL queries, and send the results to the cloud. The Eclipse Marketplace for IoT is a repository from which additional Wires components can be installed into a Cura runtime with a simple drag and drop. The Wires features aims to simplify the development of IoT edge computing application, leveraging reusable configurable components that can be wired together and which eventually allows configurable cooperation between these components. In the data flow programming model, the application logic is expressed as a direct graph, where each node can have inputs, outputs, and independent processing units. There are nodes that only produce outputs and ones that only consume inputs, which usually represent the start and the end of the flow. The inner graph nodes process the input and produce outputs for downstream nodes. The proxies unit of a node executes independently and does not affect the execution of other nodes. Thus, the nodes are arguably reusable and portable. In this way, the developer can easily prototype its solution without sacrificing flexibility and working at a live level of abstraction. The graph can be extended, added new nodes, or drawing new connection and anything else. Furthermore, the developer can take advantage of the Eclipse Marketplace integration, being able to use open source or commercial building blocks into the final solution by simply dragging and dropping a link to the Eclipse Marketplace in the Cura administrative web UI. When we are talking about the full web components, we are referring essentially to ones that are automatically distributed by Cura. First, a timer that ticks every X seconds and starts the graph. Second, a publisher that publishes every message received from a wire. It is configurable in order to use a specific cloud services. Then there are the subscriber that subscribes to a configurable topic via specific cloud service. It receives a message from a cloud platform, wraps it as a wire message, and sends it to the connected wires to the other components that are part of our wire graph. DB Store allows the storage of wired messages into a specific database table. It has rules for message cleanup and retention. There are also the DB filter that allows the filtering of messages receiving in a DB via proper SQL query, and the corresponding messages are sent as wire messages to the connected wire components. Logger component simply logs the received message, so is a default component you will try. And at the end, an asset component that allows the definition of wire channels that will be used to communicate with a field device through the associated driver instance. In the top left part of your web interface, you will find one of the most widely interesting features, the download button that allows to download the configuration of the graph and of all the components that are part of the graph. The snapshot is an XML file that have inside all the Cura properties and characterizing your edge application. And it can be used to replicate the same configuration across all the fleet of devices. To upload the store graph, the user has only to access to specific settings section inside Cura Web UI, and with one click, you will be able to apply it. Cura also provides full connectivity management to remote cloud service, enabling store and forward functionality for telemetry data and offering a policy-driven publishing system, which abstracts the application developer from the complexity of the network layer and the publishing protocol used. Cura provides out-of-the-box support to connect to different IoT cloud providers, including Eclipse Kapoor, Eurotech Everywhere Cloud, Microsoft Azure IoT Hub, Amazon AWS IoT, and more will be added in the future. This will make it possible to develop and deploy IoT gateway solutions that are not tied to a particular IoT cloud vendor. In addition, it will also allow to generate multiple data flows from a single IoT gateway routing messages based on a privacy policy, or separating telemetry data for command and control message exchanges, and employing power message routing rules, for example. Some cloud connectors are provided out of the box by Cura Distribution. Others are available as add-ons, like, for example, Eclipse Kapoor, Everywhere Cloud, Microsoft Azure IoT, Cumulosity, and for sure, AWS IoT Core we have already seen. As we talked about before, one of the most interesting features of the Eclipse IoT Hub is the full integration with the Eclipse Marketplace that should provide lots of bundles and deployment packages. You can easily drag and drop and install in your environment. Those kinds of different components you can easily download for free, allows you to visually compose your edge application without writing any lines of source code, and export and replicate this kind of configuration on one or more different devices. In this way, you can easily match the best scalable practices for an easy multi-tenant deployment. Eclipse Kapoor addresses the integration needs of IoT applications. The platform provides all the services required for the management for IoT gateways and devices in the field, including configuration management, application lifecycle management, and also remote access. It also provides the services needed to collect data from the field and integrate it into downstream applications, business processes, dashboards, and reports. In Kapoor, the integration hub between the IoT devices and the IT infrastructure, we refer to it as the IoT integration platform. Kapoor IoT integration platform is organized around the following pillars, essentially. First, an open and secure device connectivity. Reduce integration costs by leveraging the standard-based interfaces offered by the Eclipse IoT Hub. Device connectivity leverages the ISO-certified standard MQTT protocol and an open language independent data payload format. Second, device management. Reduce maintenance costs, improve your operational efficiency, and extend the life cycle of your remote devices by keeping them up to date and secure. Kapoor IoT platform has the unique ability of managing the field devices through the same MQTT connection used for telemetry data. And this is a very, very interesting features. Third, we can talk about the device remote access. Remotely access your devices to enable remote maintenance and to provide advanced assistance to issue investigation without field visits to the installation site. Four, we are referring to data management. You can collect, store, analyze any sensor or device data to drive business insights and drive new revenue. And five, we can talk about real-time data. Subscribe to sensor data streams to enable immediate data decisions and also analytics. And at the end, we for sure talk about scalability. We can start small and grow while being sustained by a very, very solid platform. So, starting from what we have already seen, we can summarize the most interesting benefits of the Eclipse IoT Hub, starting from any preliminary considerations. IoT open source based platforms are encouraged to leverage existing open source projects and IoT tools to accelerate product development. Such open source solutions have been on the IoT market for several years, typically being integrated in service provider and end consumer solution, This for 5 distinct strengths versus commercial platform offering. First, open modular architecture. The system is based on open source code and composed of separate components that can be connected together. Second, hybrid cloud, multi-cloud flexible deployment models. In fact, a cloud approach made up of more than one cloud service from more than one cloud vendor, and both public or private, essentially. The third point regards meet data sensitivity requirements, upholds the confidentiality requirements for data. The fourth topic regards the long-term scalable cost model. In fact, operational costs do not grow out of control as the platform scales. And the fifth is one of the most important topic is the community innovation and interoperability. In fact, the open source community of developers offers a unique source of innovation and interoperability between components being developed. The combination between Cura and Kapua allows customers to easily create a digital twin of any types of physical device that can be managed and controlled remotely in real time. In this, therefore, the Eclipse IoT Hub guarantees the introduction of turnkey IoT solution that is extremely functional to any kind of industrial segment, also guaranteeing some benefits that we are going to deepen below. Customers are adopting an Eclipse IoT solution can develop a custom edge application quickly and intuitively without writing any line of code and downloading and installing for free software bundles and packages directly from the Eclipse Marketplace, with the consequent reduction of go-to-market times and costs. We still proceed with a clear mindset, try to reconcile the features of Eclipse IoT Hub with the main needs and challenges we have already seen at the beginning of the presentation. Starting from that, we can make a further clarification. When we are talking about a no compromise integration, we are referring to the specific need to first being able to interface as many types of field device as possible and related communication protocols with our IoT hub. Second, being able to connect our IoT hub to as many instances of different third-party cloud platform. And third, being able to connect our IoT hub to existing web platform. Also analytics and or business intelligence tools. All these because, this is a particular large and significantly jagged market. Therefore, it requires making choices focused on the simplification of the no-compromise integration, both at the edge and at the cloud. In this, the Eclipse IoT Suite responds perfectly to this time of need. For going more deeper on two aspects, hope you will appreciate a briefly technical overview about Cura architecture. As you can see, there are advanced software frameworks which abstract and isolate the developer from the complexity of the hardware and the networking subsystems. It redefines the development and reusability of integrated hardware and software solutions. Cura essentially is a smart application container that enables remote management of IoT gateways and provides a wide range of APIs, allowing you to write and also deploy your own IoT application. CUDA runs on top of the Java virtual machine, and as we said, leverages OSGI, that is a dynamic component system for Java to simplify the process of writing reusable software building blocks. CUDA APIs offer easy access to the underlying hardware, including serial ports, GPS, watchdog USB, and more else. They also offer the SGI bundle to simplify the management of network configuration, the communication with IoT service, and the remote management of the gateway. All CUDA components are designed as configurable OSGI declarative services, exposing the service API and raising events. While several CUDA components are pure Java, all others are invoked through the Java native interface and depend on the Linux operating systems. Here we've chosen to represent a simplified architecture overview where you can find the most important services provided, like for example remote management and a really intuitive administration guide on top of that. When we are talking about third-party platform integration at the cloud, we specifically mean the integration of the edge management platform with third-party cloud platforms that are not in opposition, overlap, or competition with each other, but are able to integrate perfectly in a fitted IoT architecture that will offering a series of important benefits combining complementary building blocks. This will increase a lot the added value of an IoT hub. So let's see how through this kind of example. In the simplified representation of the underlying architecture, you will see here, we are allowed to consider our edge framework on top of generic edge infrastructure, whether it be physical, as in the case of an IoT gateway, for example, or differently in a Docker container. Using CUDA's cloud connections, we should easily interface our IoT hub both with Kapoor and the management, so the edge management platform, and for sure with the Amazon Web Services Cloud Connector, we are able to connect to Amazon Web Services IoT Core. This kind of architecture could be built in a matter of minutes by a developer is comfortably using Eclipse building blocks. At this point, let's understand how the integration at the cloud could give an added value to our IoT architecture. One of the examples that best clarifies this point is represented by a very simple XML configuration file. So what we have called CUDA snapshot in the previous slides. The CUDA snapshot contains all the elements that distinguish the configuration of our edge gateway, for example, and therefore can be easily downloaded, saved, and possible applied on any other gateway where we want to replicate our wire graph or the active cloud connectors and the firewall settings, for example, but any kind of features. Talking about scalability and easy integration regarding our IoT infrastructure, we could therefore go to inject from our Kapoor console the XML configuration snapshot containing all the properties mentioned. These for any new device that we intend to connect to Amazon IoT Core, for example. In fact, it will be enough to take the snapshot containing the core configuration from any of our gateway field devices and distribute it to the Kapoor web UI. To any other device, we can do the same things for any other device, even a new one put in place of a faulty one, for example. We are also allowed to implement this kind of feature using jobs so as to be able to schedule the distribution of a configuration update in advantage. In this, therefore, our edge management platform acquires a fundamental role and is not at all in conflict or overlap with AWS, for example, in this case, but the same will be with any other kind of third part cloud platform. In this case, AWS IoT Core represents the cloud platform where we intend publishing data, both raw and re-aggregating them in a Fusion formats to feed the analytics contained within Amazon. Kapoor, on the other hand, will be the interface through which we can manage the application flow, the alert flow, and the device management one. In this, therefore, the integration between the Eclipse IoT suite with other existing platforms is a really important added value. This is just one of the many examples we could do, but the meaning remains clear. Eclipse open source software is ideal for a not compromising integration both at the edge and the cloud, whether we are referring to an IoT architecture implemented both from scratch or in addition to pre-existed operating platform. In both the cases, all the feature benefits can even be further increased without particular without particular risks. Okay, so I think we are near out of time today. So if you have any doubts or question, you can also write me to my Eurotech email address or different in a private message on my LinkedIn profile. Thank you for your attention. Enjoy. Hope you will enjoy the rest of Eclipse events.
All right. Thank you so much, Gabriele. So we have a few questions that our attendees logged in as you were speaking. So let me start with the first one from Alexander, and he's asking, are there anything interesting for makers writing these products, or are they oriented primarily for enterprise?
Can you repeat the question, please?
I think the grammar is not perfect, but essentially, I think the question is it possible, for device makers to use Kura and Kapoor in their products, or are Kura and Kapoor just reserved for the enterprise?
No. Kura and Kapoor are both open source project that will be released 5 and 4 years ago, so everyone can approach this kind of framework and IoT edge management platform. Is not reserved for enterprises, but you can start with a simple Raspberry Pi and download from Git Kura and Kapoor source code and starting using the edge framework when you want, essentially.
Yeah, and I think there are a number in the Eclipse IoT community of people or even companies that rebrand Kura and Kapoor and use their own logos in the UI. That's possible, right?
Yeah.
Okay, excellent. Thank you. A second question now coming from Michalis, I hope I pronounced this well. How are data from different lot solutions finally stored on different cloud providers, for example, Azure and AWS, being consolidated, merged for use? Is it out of the box, or do you need to do custom development to do that?
Okay, essentially it depends. You can do both. You can create your wire graph and with the DB filter, for example, DB filter component, you can store data in the way you prefer. For example, we use in my example, I use Amazon IoT Core for the storage, because there are lots of interesting type of analytics and dashboards, and in this kind, we are using both raw data and aggregate with a Fusion component that essentially is a JavaScript filter we have created with 10 line of code. So essentially, you can store your data in the way you prefer. This is the...
All right. Okay. Thank you. A question now from Shant. Is there a way to visualize and realize the Eclipse IoT landscape and the tools within its environments? The tools from Eclipse are fantastic. However, there exists a large gap in bridging different software suites together. For example, Cura, Kapoor, Sparkplug, Tahu, Hono, Ditto, etc. How can a developer, architect, or hobbyist know when and which tool provides a near best fit for their application?
It's a good question, but I think that we have a very incredible web UI, and the WISE component are available by default, and here you can aggregate your data flow pipeline and create the management pipeline with a simple drag and drop features. So I think that the best solution, it will be start using that and try if that could be the best solution for that kind of application, and starting from that, evaluate if going on to this this kind of solution or other.
That makes sense, and I would add to that personally. We have a public mailing list for Eclipse IoT. We have a public Slack workspace that you can join. We have monthly community meetings. So if you're not sure what to use for your specific use case, please feel free to share your questions and concerns with the community over one of those channels. And there are a number of people that I'm sure will jump in and propose solutions and help you find out the best fit. We also have on our iot.eclipse.org website a projects section where you can sort according to various functional concerns, and this helps you cut down the number of potential solutions for a specific use case. But ultimately, any non-trivial problem requires some thinking, which means that you need to explain your use case for us as a community to help you out. And my advice there would be to use the mailing list, the Slack workspace to interact with the community and try finding answers there. Also, it's my role as a program manager to help out newcomers to our ecosystem with that. So especially if you are working for a company and trying to figure out what you can leverage in our toolkit, then more than happy to jump on a call and try to explore that with you. Okay, and last but not least, we've got a question from my colleague Hassan, and he's asking, from a trending perspective, we are seeing great traction between various functions of organizations from one side and IoT and edge solutions from the other side. As a product strategy expert, Gabriele, how do you see the impact of IoT and edge solutions on product and service development in your organization?
It is fundamental. There are lots of benefits increasing edge computing. We have talked before of some of that, but essentially when we talk about the implementation of edge computing solution, the first interesting thing is that you can reduce the latency, because real-time or latest near real-time requirements are provided from a good distributed solution. This concern in particular the whole part of data acquisition and transmissions, aggregation, and of course, I think that it will be a marketing increasing trend, vertiginous for any aspects. So I think that is more important working on this kind of solution and distributed architecture with an high computing edge approach.
All right, thank you. So that was the last question. So if you have a last minute question, now would be the time to type it. In the meantime, Gabriele, I think the last thing left to say is thank you. Thank you so much for participating today in our event. Thank you for all the great work you do in open source at the Eclipse Foundation on Cora and Kapoor. You and the rest of the team, certainly working with Eurotech is always a pleasure. And if people want to know more, especially about the commercially supported products that Eurotech offers on the top of Cora and Kapoor, where should they go?
I think the best solution is contact me or one of our developers that could provide all the information you want, also for the enterprise version of Cora and Kapoor, that provide any other features and the integration between the approach, the no lock-in approach, and the enterprise version of those kind of no lock-in open source products will be amazing. So all the contacts of me or one of my colleagues, you can find all the information you want, and we are available all day and all night.
Excellent. Okay, thank you so much. All right, so now this is the end of this session. So thank you everyone for attending. Thank you, Gabriele, once again. And we'll start the next session in around 10 minutes. So if you are in for the ride, you just have to stay here and you will be brought automatically to the next session. So once again, Gabriele, thank you, and see you around.
Thank you so much. I hope you will enjoy the rest of the event. So I think we will get in touch soon. Bye-bye.
Thank you.